Good morning, friends. Welcome back to my channel Coding Environment. In the last video, we have seen what is double-ended queue or what is a DEQUE. Also, we have seen how it is implemented in Java. In this video, we are going to see how we can write our own program for a double-ended queue in Java. This may be one of your interview question in any technical round. So without making any delay, let's move and see how we can implement this DEQUE data structure in Java. So for the sake of the time, I have already written all the methods like insert the element at the rear end or insert the element at the front end or delete the element from the rear end or delete the element from the front end. Let me explain these methods one by one so that we can run these methods in Eclipse and see what the output is coming. So to create this double-ended queue, we can use this circular queue as our base structure. So first of all, what we have to do as a step one is to create an empty array. So this is my first step. What I have to do, I have to create an empty array and I have to initialize this front and the rear index with -1. So this is the initial condition or the initialization value anytime when we are creating a circular array. So this my front is pointing to -1 and the rear is pointing to again -1. Let me annotate this indexes also. It's 0, 1, 2, 3 and 4. And you can see the size is as a 5, right? Now let's try to insert one element and see how this program is getting executed. Now suppose if I'm inserting an element at the rear end. So this is the rear end. Rear end is now pointing to -1. So to insert any element using the rear end, what I have to do is to check that the queue is full or not. As my front is pointing to -1 and rear is pointing to -1, you can see this full circular queue is empty right now. Also, there is a condition with which we can testify it. So to check that the queue is full or not, we can use this particular condition. So the condition what it says is if front is equal to 0 and rear is equal to size -1, then this queue is full. So if front equal to 0 and in this case if rear is pointing to size -1, which means 4. So if rear is pointing to 4, so if my R is pointing to here and if my F is pointing to here, it means that the queue is full, right? One more thing, like whenever we insert an element at the rear end, rear will be keep on moving into this direction. And when we insert an element from the front end, my front will be keep on moving into this direction. So we have to remember this. This rear will always move into that clockwise direction and the front will move in the anti-clockwise direction. Now this is the one condition, right? If the front equal to 0, if my front is pointing to 0 and my rear is pointing to 4, in this case the queue is full because the rear has reached to 4 by filling all these indexes, because it started from 0 and it would have filled 1, 2, 3 and then it would have reached to 4, right? Now if this condition is true, it means that the queue is full. Also, if my front is equal to rear -1, it means if my front is equal to rear -1 can happen if suppose my rear is pointing at this location. Suppose my rear is pointing at this location and the front is pointing at this location. So when this situation can happen. Now suppose both my indexes started from 0 and it keep on filling the data. So rear would have filled, suppose here it has filled 1, here it has filled 12 and here it has filled 13. Now the front also keep on filling the data. So if front is started from here, it would have filled suppose 5 here and 6 here. So this is the condition, right? If my front is pointing to index 3 and my rear is pointing to index 2, you can see all these data are getting filled, right? So it indicates that the queue is full. So this is the condition which we have to see that the queue is full or not. If the queue is not full, we can go and insert an element at rear index, right? So now let's insert one element and see how these things are getting inserted. So let me erase everything. And now suppose if I want to insert an element at the rear end, so at which position you think that the element will get inserted? The element will get inserted at the 0th index, right? So 0, 1, 2 and 3, 4. And suppose I want to, at the first time, I want to insert an element 5. So how the 5 will get inserted here? The queue is not full. This condition will get passed. The front is pointing to -1, right? Now this condition is getting satisfied. The front is pointing to -1, and in this case, my front and rear again point to here. So F is also pointing here only, and my R is also pointing to this location only. So in this case, this condition will get executed, and after this particular line will get executed. What it says, array rear equal to key. Now here key is our 5, and element will get inserted here. Now suppose if I want to again insert an element 6 here, so what will happen? It will go and check that the queue is full or not. No, the queue is not full. The front is equal to -1. No, because the last time we moved front and rear from -1 to index 0. So both is pointing to 0. After that, it is checking that the rear is equal to size -1. This condition will also not get satisfied because rear is pointing to 0 and size -1 value will be 4. So this is also not getting satisfied. So in this case, what will happen? It will happen rear equal to rear plus 1. So it was pointing to 0 and plus 1 will bring the rear from 0th location to the first index, and then it will put 6 here. See, in this way we are going to insert the elements into the rear index. Now suppose I want to insert an element at the front index. So it will again go and check that the queue is full or not. So in this condition also you can see that the queue is not full, right? And if the queue is initially empty or not. Now the front is again not pointing to -1 because we have inserted already 2 elements here, and the front is pointing to 0. After that, if the front is pointing to 0, if this condition is getting satisfied here, right, because that still this front is pointing to 0, our front will move from 0 to index 4. Our front will move from index 0 to index 4. Now, how it will happen? You see here, this front equal to size -1. So size was what? 5. 5 minus 1, right? This answer will be 4. So our front will move from there to this location. And then we can, if suppose you are inserting an element 10, it will get inserted here without any issue. So see, the rear is moving into this direction while insertion, while the front is moving into this direction while insertion. So this is the way we are going to insert an element from the rear end or from the front end. Now let's see how we can delete an element from the rear end and from the front end also. So this is the two methods which we are going to use for deletion of an element. Now to check that now suppose if I have to say that delete an element from the rear end, in that case what will happen? This is my rear end saying, in this case again we have to go and see that the queue is empty or not. If the queue is not empty, then only we can go and delete the element site. If the queue is empty, we cannot go and delete. There is no element to delete only from the queue. So how we can check that the queue is empty or not? So this is the condition. This front is equal to -1. You remember that the front and the rear was initialized with -1 at the time of initializing that circular queue, right? So if the front is equal to -1, it means there is no element inserted into that circular queue. Also, if my front is equal to rear, in this case occurs only when there is only one element into the queue. You have seen that if suppose this is 0th index, this is 1, this is 2, this is 3, and this is 4. Now if my F is pointing to here and my R is also pointing to here, in this case there is only one element here, right? Suppose there is only one element here. Now if this condition is getting satisfied, there is only one element. So if I have to delete this element also, after that there is no element into this queue, right? So what I have to do, I have to again initialize this front equal to -1 and rear equal to -1. So that's what we are doing it here. Now if suppose this condition is also now suppose we have inserted like 5, 6, 8, 10. Now suppose you want to insert from the rear end. In this case, this queue has more than one element. I wanted to go into this particular condition, in these conditions, so that I can show it. So that's why if this condition is also not getting satisfied because the queue is not empty, there is more than one element into the queue. So this condition will not get satisfied. This condition will not get satisfied. And if the rear is pointing to 0, in this case, the rear is not pointing to 0. The rear would have moved here, right? Because we are keep on inserting into this direction. So rear is now pointing to index 3. So if the index is 3, which is not satisfying this condition, it will go and execute this one. So from 3, rear will move to index 2, correct? Now similarly, if I have to move from, like suppose after that again I want to delete from rear, it will move from 2 to 1, right? So same way here, if my R is pointing to here, it has to move from index 0 to index 4, correct? So how it can move from index 0 to index 4? If I do size -1, it will go to that 4th index. So this is the way we can delete an element from the rear end also. So see, we covered inserting an element at the front end, at the rear end, and also we covered how to delete an element from the rear end. Now this is the last method which we are going to cover, is to delete an element from the front end. Now suppose there is one more element here, this 19 is the element, and it has been inserted from using the front keyword. So now the front is pointing to index 4. So f at this position is equal to f4. Now this, check this condition, is the queue is full or not? Sorry, this is not full, this is empty. So we have to check that the queue is empty or not. If the queue is not empty, again we can go and check that the front is equal to rear or not. So these two conditions are same what we have seen into this method. Now if my front is equal to size -1, it means if my front is pointing to 4, because size is here 5, so 5 minus 1 is equal to 4. So if my front is pointing to 4, where it has to move? It has to move to index 0, right? So if my front is equal to size -1, my front will move to 0, or else front will move to front plus 1. Now suppose it has inserted from 19 and f is pointing here, equal to 10, and instead of this r is pointing here, r is pointing at this location. So in this case, it has to move from index 3 to index 4, right? So f, that front plus 1. So if I do this, my front will move here. So these are the basically 4 operations in a doubly ended queue. That is the or insert an element from the rear or the front end, or delete the element from the rear or the front end. Now let's move to Eclipse and see how these things are getting executed and what the output we are getting. So let's move to Eclipse. So for the sake of the time, I have already written this program. So now let's examine these methods one by one and run this code in a debug mode so that we can get to know how these things are getting executed. So the important methods is like insert the element into the front, or insert at the rear. So let's examine this also. Delete the element from the front, or delete the element from the rear. So these are the elements we are going to examine. Now let's run this code into the debug mode and see what things we are getting. So see, this is the first thing we are going to do. We are going to initialize this doubly ended queue or the circular queue. So while initializing, if you see, we are going to initialize this front equal to -1 and rear equal to -1. So this is the initialization part what we have to do. Now suppose I initialized it, and now if I want to insert an element at the rear end, so This is the thing which I'm going to do, insert the element at the rear end. So in this, what the things we have to check? We have to check that the queue is full or not. Because the queue is not full, we are going to check that is there any element into the queue or not. So if front is equal to -1, it will say that there is no element into the queue. So it will go and set that front equal to 0 and rear equal to 0. So for this, I can show you here. So this is the initial condition of that circular queue. Now, if you see, my front is pointing to 0 and now my rear is also pointing to 0. After this, we have to put this element 5 at location 0 or at index 0, right? So this is going to do the same thing. Now see, it inserted the key or the element 5 into the index 0. Now suppose again if I want to insert 10 at the rear end, where it will go and insert it. It will go and check that the queue is full or not. And so see here. So before inserting the element 10, what is the value in the queue? So 5 is there in the queue. Now from 5 to these 4 places are still empty. And rear is now pointing to index 0. So the rear is pointing to index 0 and the front is also pointing to index 0. Now this rear is equal to size -1, no, because size is equal to 5, and if you see 5 minus 1 equal to 4. So this condition is not getting satisfied. Rear will move from index 0 to index 1 and the element key whose value is 10 will inserted at the index 1. So see, index 1 it got inserted. Now suppose again if I want to insert an element 15 at the front, can you guess where that element will get inserted? See, the rear was moving into the clockwise direction. So this is the clockwise direction, 5, 10. Suppose if I want to insert one element at the index 2, you can do. So this is the clockwise direction. The anti-clockwise direction is in this way. Like you can see from here it will start. Now suppose if you want to insert the element 15, it should get inserted at this position, because we have to do what? If my front is equal to 0, so let's insert this. So if my front is equal to 0, this condition is not getting satisfied. If my front is equal to 0, my front equal to size -1, right? And if this is the one, what is this index value? This index value is 4, correct? Size -1, size is 5 and -1 equal to 4. So it will move into this particular location, 4th, right? And this will insert the element at this. So you've seen, right? I inserted the element 5 and element 10 using the rear method and inserted this 15 using the front index. This is the insertion thing. Now suppose if I want to delete it, this is the thing, we can print it here also. Now suppose I want to delete from the rear end. Now how I have to delete? So if I'm going to delete from the rear end, this value should get deleted, right? Because the rear is pointing to here and my front is pointing to here. So let's delete the element. The queue is empty or not? No, that queue is not empty. So we can see here that the queue is not empty. Rear is equal to front? No, because rear is pointing to index 1 and front is pointing to index 4. So this is also not true. Now if rear is pointing to 0, no, the rear is also not pointing to 0. Rear is pointing to index 1. So if it is pointing to index 1, rear -1. So it has to basically move from index 1 to index 0, right? So see here, it moved to index 0. So if I do rear, it moved to index 0. So this is the deletion. Now it doesn't matter what the value is here. My rear is pointing to here and my front is pointing to here. So I can insert any value in these 3 locations. Similarly, if I want to, here it is just getting that rear value. So this is normal thing. Let me go to this again. I have explained insert in front. So because we have already inserted, let's show you that particular thing. Size, yeah, we inserted 15 last time. Again we inserted 15, so it inserted in that way. And now suppose delete in front. So this delete in front should delete what? Let's go and see that array. So my front is pointing right now at this location and my rear is pointing at this location. So if I want to delete the front, this 15 should get deleted and my front value should move from 3 to 4, right? So this front is not pointing to size -1. Size -1 value is this one. So my front is pointing to 3. So it will go here and it will move from 3 to 4. So 3 plus 1, 4. So see, this is the way we are going to insert and delete the element from the both sides of the queue. And that's what the doubly ended queue, right? Insert and delete an element from both sides of the queue. So hope you liked this video. If you have any doubt, you can write it in comment section. I will try to answer it. If you liked it, please subscribe to my channel and stay connected. Till then, have a great day and goodbye.